Hi class, today we are having a note on transforming sinusoidal functions. So this is actually quite just a quick note, just an example of how you can take a situation and transform the function, create the equation. Okay, so today our situation is a ride at an amusement park. Okay, it gives us the maximum height and the minimum height, and it gives us the time it takes to complete one turn. Okay, it also tells us that the highest point occurs at 0 seconds. So they want us to graph this model for the first two revolutions and create a cosine and a sine model to represent the situation. So first of all, let us graph this. So it says it completes one turn in 5 seconds. So I'm going to actually show two different turns. So each one will just be 1 second, 2 seconds, 3, 4, 5, 6, 7, 8, 9, and 10. So this will be time. And then the height will go up by 1 as well. So 1, 2, 3, 4, 5, 6, 7, and 8. So notice that it said that the highest height is at 7.5 and that it occurs at 0 seconds. So there we go. Here's 7, so 7.5 is right there. Okay? Then it said that the wheel completes one turn in 5 seconds. So at 5 seconds, it will again be at its highest height. Okay, we can then assume that the lowest point will occur halfway between the highest points. So the lowest point, it said, was 1.5 meters. So halfway between 0 and 5 is 2.5. It would be at 1.5 meters. So there we go. And then this pattern will repeat again. So actually here, let's talk more about the pattern. So halfway between here and here, it'll be on the axis. So we can figure that out later with some work. At 10 seconds, we know it'll again be at a maximum. And then at 7.5, so halfway between, it will then be again at a minimum. Okay, so we can start to do our curve, but I'm actually not confident enough because I want to be able to find the axis. I just want to show those points there. Okay, so let's go back up here and come up with our A, K, D, and C values. So our max is 7.5 and our min is 1.5. So between that, we can find the axis. The axis is halfway between those two. So we just need to find the average. So 7.5 plus 1.5 divided by 2. So that is 9 divided by 2, which is 4.5. So therefore, C is equal to 1.5. That is the C value, is the axis, which we learned in the last note. So we can take a horizontal line at 4.5 to mark the axis and label it with the equation. Now I'm doing it with the equation y equals because that's the equation of the horizontal line. This C refers to the parameter in the equation. Okay, now the amplitude, remember, well, that should be 4.5. The amplitude is the distance from the axis to the max or the axis to the min. So the amplitude, I'm just going to do 7.5 minus 4.5, so that's equal to 3. And that makes sense because it's 3 units up to the amplitude or down, sorry, from the axis up or from the axis down. So that is equivalent to the A value, so our A value is 3. Okay, the period here is 5, which is given to you. So therefore we can determine our K value, which is just 2 pi divided by the period, so 2 pi divided by 5. So there's our K value. Now, the phase shift depends on whether we're using cos or sine. So now at about 1.25, we're at the axis, and here again halfway in between, so 3.75. Okay, so you can choose to put the points on the axis or not, but either way, you have this curve, which, sorry, again, on the trackpad is not the best, but there we go. So let us create our function then. So we'll say let h at t represent height above the ground in meters after t seconds. Okay, so we'll make a cosine function and a sine function. The cosine function is easier because there's no phase shift. Okay, because it starts at a maximum and goes down, which is what a cosine curve normally does. So now we just need to do h at t equals a, which our a value is 3, cos k, our k value is 2 pi over 5, and then t, no d value, plus 4.5. And there you go. Now we can do our sine curve function, which again is the same thing, but now we have a phase shift. So when we think about the phase shift, we have to think, how far has sine been moved to the left or to the right? So remember, a sine curve normally starts at the axis and then travels up. So we have to say, how far is it from where it should be, which is over here, to where it starts on the axis and then goes up. So it's this distance from here to whatever this point is. That's the d value for the sine curve. So that's 3/4 of the way. So you can write here, it says, where does t hit axis going up? So you'll notice that that happens at t equals 3.75. Okay, that's the first time where the curve is on the axis and it's about to increase. So now we just write our function with that. So h at t equals a, which is 3, sine, bracket 2 pi over 5, and then start a new bracket, t minus 3.75, because it's been shifted to the right, and then plus 4.5. So there you go. That's our example where you're given a situation and you have to come up with the equation. Thanks for watching. I hope you learned lots.